Hello students, I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today I am going to discuss about the insulation coordination. So before going to the deep study, we have to know what is insulation coordination. Insulation coordination is the process of knowing the insulation level of the power system components. So, what are the power system components? The power system components are the circuit breaker, relay, switch gear, or various types of apparatus which are used in power system. In other words, it is the process of determining the insulation strength of the equipment. The internal and the external insulation of the electrical equipment is exposed to continuous normal voltage and temporary abnormal voltage. The equipment insulation is designed in such a manner so that it withstands the highest power frequency system voltage. Occasionally, temporarily power frequency over voltage, occasional lighting surges. The equipment of power system has assigned the rated insulation level and their capability can approved by applying different types of test like dielectric strength test, the insulation level test. The requirement of insulation is determined by considering the following factors. These are as follows. The highest power system frequency voltage. The AC power network has different nominal power frequency voltage like 400 volt, 3.3 kV, 6.6 kV, etc. When the system is lightly loaded, the power frequency voltage at the receiving end of the line rises. That is known as the Ferranti effect. The equipment of the power system is designed and tested to withstand under highest power frequency system voltage like 400 volt, 3.6K, 7.2K, etc. without internal or external insulation failure. Now, the temporary power frequency over voltages. So here you can see that is the temporary power frequency over voltage which is rises here. There's a time and that is the value of the voltage. You can see here the value of voltage is not same all the time. The temporary overvoltage in power system can be caused by the load throw off, fault, resonance, etc. When the load is suddenly cut down, so their frequency is about 50 Hz and lesser peak. The lesser rate of rising and long duration, second even minutes, the protection against temporary power frequency over voltage is provided by IDMT relay. The IDMT relay is connected to the secondary of the bus potential transformer and circuit breaker. The relay and circuit breaker takes action within millisecond and protect the system from temporary over voltage. So it is over voltage type relay, and if it persists, then there is a damage of insulation occurs. So there we have to install the IDMT relay. Now the next one is the transient over voltage surge. The transient over voltage surge in the power system can be caused by lightning, switching, restriking, traveling waves, etc. It is a very common fault. We know that transient over voltage surge. The surge of the power system has a high peak, high rate of rising and lasts for few 10 to 100 of microsecond and are therefore called the transient. We know when the power cut occurs and when it is the power lines become healthy, and when the power on occurred or switching occurred, then the transient phenomena has come. Okay, and it persists for 10 to 100 of microsecond. This surge can cause spark over voltage and flash over at sharp corners between phase and earth. At the weakest point, the breakdown of gaseous, liquid, solid insulation, failure of transformer and rotating electrical machines. The failure rate due to lightning and switching has been minimized by proper insulation coordination and the surge or lightning arrestor. It is very important. The several types of protective devices are installed on the network to intercept the lightning stroke and minimize the peak rate of rising of surge reaching the equipment. Okay. Now you can see that is the switching surge. When the switch is on, you can see here the voltage is increased. Okay, and the time is very small, 1 to 3000 microsecond. You can see here the voltage is increased in nature. It is a switching surge when the transient has come, and that is the lightning surge. One to 100 microsecond time. You can see the value of the lightning surge is more than the switching surge, and that is the lightning surge. Okay. Now the withstand level of the equipments. So here you can see the crest voltage in kV, that is the arrestor, and that is the time in microsecond. And A and B, these are the apparatus. Okay. So that is the crest voltage in kV, which is increased here, and it is a time, it is a peak value, then it is reduced at B point. The basic insulation level is the reference level expressed in impulse crest voltage with a standard wave not higher than 1.2 by 50 microsecond. The apparatus or equipment should be capable of withstanding test wave above BIL. Insulation coordination implies the selection of the insulation of equipment with regards to its application to minimize the undesired incident due to voltage stress caused by the overvoltage in the system. Within the system, insulation breakdown means the correlation of the insulation breakdown of the various components of a power system to the insulation of the protective device used for the protection of that equipment against overvoltage. So that's all for today. That is all about insulation coordination. Thank you.